In this video, I just want to give you a review of scientific notation. Scientific notation gives us a way to write really large numbers or really small numbers in terms of powers of 10. For example, if we had the number 523,000, we can write it as 5.23 times 10 to the 5th power. How did I know that? Well, in standard or normal notation, the decimal point is right here. In scientific notation, we always write it so that there's exactly one digit to the left of the decimal point. In this case, the one digit on the left of the decimal point is the 5. We need to count how many times we have moved the decimal point, and that will tell us how many times we have to multiply by 5. We moved it once, twice, 3 times, 4 times, 5 times. So we'll have to multiply it by 10 5 times. So we get 10 to the 5th power. It's important to remember that anytime you have a number greater than 1, the exponent here is going to be positive because we have to multiply by 10 to make the larger numbers. So let's try another one. It's a really big number. We can look and figure out, oh, we have one comma, these are the thousands. We have another comma, these are the millions. These are the billions. This is actually on the order of 1.57 trillion. But all we need to do to write it in scientific notation is put the first digit that's not a 0. It can't be a 0. It has to be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. And then we put our decimal point. So 1.57. And then we just need to see how many times I'd have to multiply that by 10. The decimal point was originally here. I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 10 to the 12. You'll remember that a trillion is 1 times 10 to the 12. So that would be our answer. Now, if we're writing numbers that are very small, numbers like these can be written in scientific notation, but this time when we do it, we actually need to divide by 10. So we still move the decimal, goes right there. So this would be 4.56. But to get the original number back, we wouldn't have to multiply by 10. We'd have to actually divide by 10 1, 2, 3 times because we moved the decimal 3 places. So anytime we have numbers that are less than 1, we know that that's going to be written in scientific notation with a negative. Let's do one more. Make it a really small number. So when we go to write that in scientific notation, we want the decimal point right there. So it'll be 8.23 times 10, and then we count. 1, 2, 3, 4, 5, 6, 7, 8. So we have 10 to the negative 8. If I took 8.23 and divided it by 10 8 times, this is the answer that I would get. Okay, so that shows us how, if we have a number in standard form, how we put it in scientific notation. Now, it's really important. There's a lot of numbers that are equal, but that doesn't mean they're in scientific notation. For example, we can have the number, just make up an example, 2.58 times 10 to the fourth. But you could also have 25.8 times 10 to the third, or 0.258 times 10 to the fifth. If you put those in a calculator, you would get the same thing each time. You get 25800. That'd be 25800. And that'd be 25800. So all three of those are equal to 25,800, but the bottom two are not scientific notation. The reason they're not scientific notation is because they don't have exactly one digit to the left of the decimal that is not zero. This has only the two. This has 25, that's two digits, and this has a zero, and that's not acceptable either. So we want to make sure you recognize scientific notation. These are all equal, but only the top one is correct. The other thing we want to talk about with scientific notation is, how do we go from scientific notation to standard? If you have a number with a positive exponent, 5.3 times 10 to the fourth. If the exponent is positive, this means you're multiplying by 10 4 times. That means the number is going to get larger each time you multiply. You're going to move the decimal 4 places to the right. So instead of being here, if we move it 1 place, we get 53. If we move it 2 places, we get 530. If we move it 3 places, we get 5,300. And finally, if we move it 1 more place, we get 53,000. So this would be equal to 53,000. Alternately, your calculator, if you type something in scientific notation into your calculator, it can probably convert it to standard form. Excuse me. But remember, if the exponent's positive, we know this is a number that's larger. It's got to be bigger than 5 because we're multiplying it by 10. If we have a number with a negative exponent, let's just do the same, 5.3 times 10 to the negative 4. That means we have to divide by 10. So instead of having 5.3, if I divide by 10 once, I'm going to get 0.53, but I'm not going to stop there. If I divide again, I'm going to get 0.053. So 2, 3, 4 times. That's where the decimal goes. So this would be 0.00053. That's tenths, hundreds, thousands, 10,000s, hundred. That's 50, instead of 53,000, that is 53 hundred thousandths. Tenths, hundreds, thousands, 10,000s, 100,000s. Okay. That's just a quick review of scientific notation.